All right, guys. So today we're looking at properties of parallelograms. I'm going to teach you 6 different properties, and you're going to use them in 2 ways. So the first way that you're going to use the properties is if I tell you something is a parallelogram or indicate that it's a parallelogram, you need to find missing pieces. All right. The other thing that I'm going to give you is, well, what if I just give you a quadrilateral and I tell you certain information about it? Based on these 6 properties, do you have enough information to say that that quadrilateral is a parallelogram? All right, so basically what you're looking for is, do you have any of the 6 properties? All you need is one of the 6 properties to be true, and then you can say something is a parallelogram. All right? So I'll kind of talk to both as we go, but let's go ahead. And first of all, before I move on though, does everyone know what a parallelogram looks like? Could you draw a parallelogram for me? Or describe a parallelogram? All right, yes, so we would draw a figure where the opposite sides are parallel, right? They don't have to be the same length, but in general, a parallelogram is going to look something kind of like this. All right, so most of you guys already know that. So a parallelogram is a 4-sided figure, which means it's a quadrilateral, right? It's just a very specific type of quadrilateral. So let's go into the 6 properties and see what they tell us. Property number 1 says that both pairs of opposite sides are parallel. Okay, something to make sure that you're watching is that for this property, you need to know that both pairs of opposite sides are parallel, not just one pair of opposite sides are parallel. All right, go ahead and copy that down. I'm going to give you the information for the example. All right, so hopefully that was enough time for you to copy down the property and think about it. I've given you 3 points, and I want you to find a 4th point so that the figure formed is a parallelogram. All right, now we know that we need the opposite sides to be parallel, which means what, in terms of a coordinate plane, how do you know when lines are parallel in a coordinate plane? What was that? Very good. You want them to have the same slope, right? So let's say that I want to put a point kind of down in this region. I can count the slope between B and C, right? And then recount that off of A. And that would mean that I've found a line segment that is parallel to BC. So if I count the slope between B and C, my slope is up 1 over 4. All right? So all that I have to do is count that from A. I just take up 1 over 4. And I can put a point right there. I know that these 2 lines are parallel. I should also check, because that's just one side, these are parallel. I should also check that BC, and we'll call this point D, and DC, or AB and CD are also parallel. So what is the slope of AB? Go up, how many am I going up? Yep, 5 over 2. Is that the same from D to C? Up 5 over 2. So I have found that both pairs of opposite sides are parallel. Remember that these little arrow marks mean parallel. Okay, I'm going to erase what I just did and ask you something. So that definitely works. That would give me a parallelogram. Can anyone find another point that would also give me a parallelogram? A different point. And it might not fit on the grid. I'm trying to see if it will. It looks like it's going to go off the grid a little bit. Let me, I'm going to move C in just a little bit to make this easier. So let's say that C were right here. Hold on. C were right here. Now if C were right here, the point that we would have just done would have been to count up 1 over 2 instead. So up 1 over 2 would have put me right here, right? And that would form a parallelogram. Can anyone see a different point from that one I just drew? Julie?
From A, go over to and then like down 1.
So over to this way, and then down one. Very good, because I can also count from C going back to down one rather than up one over two, right? So I can move this way, and would you all agree that, gosh, this thing gets tricky. All right, would you all agree that this forms a parallelogram? If I connect like this, right? So if I give you 3 points, there are more than just one, there's more than just one possibility to form a parallelogram. One of your homework questions is actually going to ask you, if you get 3 points, how many different ways could you make a parallelogram and where are they? So you guys are going to kind of have to look for them. I've shown you the ways that you can do it here. You're going to have to extend it just a little bit. Are there any questions on that though? No? All right, on to the next property. Okay, go ahead and copy this down. I'll give you the information on the figure. Okay, so this property says that both pairs, and again, the key word here, we need both pairs of the opposite sides to be congruent, not just one pair of opposite sides to be congruent. All right. So I am telling you that the quadrilateral is a parallelogram, and I want you to find x and I want you to find y so that this is true. Who can tell me where I should start based on this property?
Well, all the opposite sides are equal to each other.
All right, so this side should be equal to what? X plus 13. Okay, so I can say that x plus 13, or let's start with the 3x. So 3x minus 1 is equal to x plus 13. Okay? Why would I not start by writing that 5x is equal to y minus 5? That's true, right? These two things are equal? Yeah, because there's two different variables, so you won't be able to solve it. We need to find one of them first, and then I can deal with the two variable setup, right? All right, so let's go ahead and look at this. If I subtract my x over to the left-hand side, I get 2x minus 1 equals 13. Add 1 over gives me 2x equals 14. So x equals 7. So I found x. And now I need to find y, which I can now use the other two sides. So I can now use the fact that this side is equal to my side that's 5x, right? So when we set that up, we get that 5x is equal to y minus 5, which would be a problem at first, but now I know what x is. So I can plug in 5 times 7 equals y minus 5. 5 times 7 is 35. Okay, so what does y equal?
40.
Yep, add your 5 over and you'll get that y equals 40. So I have now found x and y that force the two opposite sides to be congruent. And if you know that both pairs of opposite sides are congruent, it's a parallelogram. Why is it not enough to say that just one pair of opposite sides is congruent? What kind of a figure could have just one pair of opposite sides congruent but not be a parallelogram? Can anyone think of what that shape is? Trapezoid. Very good. So if you look at this figure I'm drawing right now, these two sides, let's say, are congruent, but is that a parallelogram? No, because I would need this side and this side to be equal as well. So that's why we have to show, again, kind of pointing out that I've circled both. You need both pairs of opposite sides to be congruent. That's the same thing with the property number 1. You need both pairs of opposite sides to be parallel, because if you only have one pair of parallel sides, again, it could be a trapezoid, right? So that's why you need to show both things you need to show parallel or congruent for both pairs of sides. Any questions on that?
So a parallelogram is just a square
Could be a square, could be a rectangle, could be something like this figure where it's kind of a lopsided rectangle.
So that's it.
Yeah. Okay. Go ahead and copy property number 3. I'll give you the example problem. Okay, so this property says that both pairs of opposite angles are congruent. All right, so we want to decide whether we have enough information here to confirm whether or not this quadrilateral is a parallelogram, and you need to be able to explain it to me specifically. You can't just say, yeah, it looks like the opposite angles are congruent, right? You have to actually show me that the opposite angles are congruent. So is there one pair that's really obvious to you right now, Fletcher?
Well, the opposite sides,
Whoa.
160 and 160.
Right. So I have marked one of the pairs of opposite angles for you. I've given you the swoop marks, which tells you, yes, those are congruent. So this angle down here definitely is 160. One set of angles is not enough. I could have, and I'm just going to kind of give you the alternative. Don't draw it, but just watch. I could have a situation like this, where these two opposite angles are congruent, but the top, like this one is way smaller than this one, right? So again, one pair of opposite is not enough. You need more than that. So we need to show that if this is a parallelogram, I need to show that this angle and this angle have the same measure. How can you tell me what the measures of those angles are? What do you have to find in order to tell me that? Fletcher? You need to find x. Now, based on last section, you guys should be able to find x for me for no problem. That's what we did during the last section. So I want you to take a second, find x. And I'll put the solution up here so you can check it. Okay, as I'm walking around, the most common mistake that I'm seeing is that you guys are setting equal x minus 5 equals 2x. I have not actually told you this is a parallelogram yet, right? I'm asking if it's a parallelogram. So if you don't know it's a parallelogram, can you use any of the parallelogram properties? No. So you cannot say that these two angles are equal when you don't know that yet. That's what you're trying to show me, is if they are equal. Go back to section 6.1. As of right now, all you know about this thing is that it has 4 sides, right? What do you know about all the angles in any 4-sided figure? In any quadrilateral? They all add up to 360. That doesn't have to be a parallelogram to have that property. Any quadrilateral has to add to 360, so that's the first thing you should do here. You're going to get an x value that will make that true, and then you're checking to see if those opposite angles are in fact equal in that case or not. Right? So your setup for this should look like 160 plus 160 plus 2x plus x minus 5. All of that has to add up to 360. That's true in a parallelogram. That's true in any quadrilateral. Right? That has to happen. Okay, so if I add all this up, 160 plus 160 is minus 5. That's going to give you 315. You've got plus 3x when you add your 2x and your 1x equals 360. What's 360 minus 315? And a 45 divided by 3. So you know x is 15, which means that you should now be able to tell me what each of those angle measures are. So what is this measure? When I plug in 15 minus 5, I get 10 degrees. In this angle measure up here, I get 2 times 15 is... So is this a parallelogram? No. And you have specifically shown me that, hey, these are what the angles would have to be a quadrilateral, and they don't have opposite. It doesn't turn out that both pairs of opposite sides are congruent. So that would be your explanation. And remember, notice that I highlighted the explain part. The explanation is what I'm most interested in, because you can easily say yes or no and take a 50-50 shot. I want to know if you understand why your answer is true. Okay? So for this, the answer that I would expect to see is this is not a parallelogram because although one pair of opposite angles are congruent, And that's which angles are those? The 160s, right? The other pair is not. And we need both pairs to be equal, because we found that the one pair is 10 and the other pair is 30. You do also have to show me the specific numbers. You can't just take a wild shot and say, oh, that other pair isn't equal, and not show me that they actually aren't equal. You have to show me the work. That's what I am most interested in. All right, not just guessing. Are there any questions on this problem? Anyone who doesn't understand why I can't just go and set x minus 5 equal to 2x in the way this is worded? Right? If this had been worded as, this is a parallelogram, find x, then that's exactly what you would do, if I tell you it's a parallelogram. If I haven't told you it's a parallelogram and you're trying to show me, then you cannot use the property until it's true. All right? Okay, let's look at the next property. 1 second. Okay, so property number 4 says that if you have a parallelogram, or if you want a parallelogram, then consecutive angles, both consecutive angles to one angle, should be supplementary. So first of all, can anyone explain to me which angles up here, and I'll go ahead and put some letters around so you can easily tell me. If this is A, B, C, and D, which angles are consecutive to A? B and D. Very good. Just the next door neighbor angles. What does supplementary mean? They should add up to 180 with the angle that I'm starting with. So if I want to find angle B, what would I do? Yeah, so 180, subtract off your 37, you get 143. So that's what angle B should be, right? And also, which other angle should be 143? Angle D should also be 143. All right, because both of those are consecutive to angle A. What should angle C be? Because, yeah, and we're assuming, I didn't actually write it, but we're assuming, I told you at the beginning of this, that we're assuming it's a parallelogram. So since I have told you, yes, it's a parallelogram, you can set the opposite angles congruent, right? If I didn't tell you it was a parallelogram, you wouldn't be able to say that. Yeah. Any questions on that particular problem? Okay. Next property. Okay, so property number 5 says that both of the diagonals bisect each other. What does the word bisect mean again? Split it exactly in half. And I'm saying that about both of the diagonals. So in other words, this diagonal here is the same as its other side there, right? Also on this diagonal, I know that both of these guys should also be congruent, right? So if I want to find G, what am I going to set the 2G minus 3 equal to? Am I going to set it equal to 1, or am I going to set it equal to 5? 5. Very good. So I gave you more information than you need here. And you needed to pick the right piece to set things equal to, right? So here we get 2G minus 3 equals 5. Add my 3 over, I get that G equals 8, or I'm sorry, 2G equals 8. So G equals 4. And I've answered the question, right? Can you guys tell me, just kind of for a little added benefit, what is this side equal to? Yep, very good. So that side is equal to 1 because, again, I should be splitting everything in half. Questions on that particular property? Yeah? Yeah. Yeah, so I set 2G minus 3 equal to 5. So if you plug in G as 4, you get 2 times 4 is 8, minus 3 is 5. Got it? Okay. Okay, so this last property says that if you have one pair, and that's kind of the key word here this time, is that I'm only looking for one pair of opposite sides. So remember in property number 1, I needed to show that both pairs of opposite sides were parallel. Or in property 2, both pairs of opposite sides were congruent, because otherwise it could have been a trapezoid, right? That's what we showed. Okay? So if you're somebody and you say, oh, I don't really want to check all 4 sides, you can choose one pair of opposite sides, but for that pair of opposite sides, you would have to show both parallel and congruent. Okay? All right. So I've given you a set of coordinate points, and I want you to algebraically show me that this is a parallelogram, or if it's a parallelogram. And I'm going to say based on this property, all right? So what you need to do is show me that one pair of opposite sides in this parallelogram has parallel properties, which in a coordinate plane, how do we show parallel? Same slope, very good. So I will want to show that that pair of opposite sides has the same slope. And I'm also going to need to show that they are congruent, which means how do I find lengths between 2 points in a coordinate plane? Distance formula. So I'll use the distance formula to show that they have the same length as well. I have 4 things that I need to show then. 2 slopes and 2 distance formulas, right? Okay. First step, and this is a silly step that a lot of people for some reason forget, you have to make sure that you are choosing sides that are opposite, right? If you just pick a random set of points and you choose sides, like for an example, I'm going to draw this little sketch up here so that I can use it as a guide. We assume that the parallelogram is given to us in order. So in other words, the points were ordered for me, A, B, C, D. I'm going to go around the figure in order, A, B, C, D. The reason why I point this out is that if you didn't draw the figure and you use the points A, B, and B, C in your work, are those opposite sides? B, C, and A, B? No. So if you didn't check this and you use those 2 sides, you are not going to get anything that's good. All right? So make sure that you draw this little sketch so that you can clearly see where are my opposite sides. Now, whether you choose to use BC and AD, or AB and CD, that doesn't matter. They just have to be opposite sides. Which pair do you guys want to work with? It doesn't matter, but AB and CD? All right, so we're going to work with this side and this side. So step number 1, sketch out a little figure and put your points around in order and identify where your opposite sides are, okay? The next step is to show me that the 2 lines are parallel. So I will show some work. I'm going to label my work as saying this is my work to show that things are parallel or if they're not parallel, either way. So make sure, and this is going to be really important to me, make sure that you are labeling all of your work on these problems. Like I said, there's a lot that goes into it. If you get the wrong answer and you haven't labeled stuff for me, I am not going to sift through all of it. It will take me about 10 minutes to figure out your problem if you don't label things, and I'm not going to do that for 130 of you, all right? So make sure you're labeling things if you want the credit. If you're trying to find that things are parallel, label that. What formula am I looking for to show that things are parallel? What formula am I using? For parallel? What did we say we look at for parallel lines? We look at the slope. What letter do we use to denote slope? M. Now, if I just write M, is that enough? Have you told me which points you're looking at?
Nope.
No. So you should write M to tell me you're looking at slope, and then AB so that I know that you're looking specifically at the slope of AB. Now, if you don't write the M on that, I am going to assume that you're finding the distance. So the M tells me specifically that you're looking for the slope. Okay? Are we all understanding how I'm going to be very nitpicky about the notation on this? Okay? So make sure you're following my notation. All right, what is the formula for slope? That would be if it was an equation or a line form, but I've given you 2 sets of points. So what's the formula if you have 2 points? Close. Y2, remember slope is rise over run. So rise is talking about y values, right? So you would want to put your y2 minus your y1 on top. all over your x2 minus your x1. You need to make sure you're getting these slope formulas correct, okay? You're going to be doing this a lot this chapter, so make sure that you get familiar with the slope formula. All right, so if I'm looking at the points A and B, my y2 value, so you might be one of those people that likes to go through and label your points, so you might, and it's going to be kind of squeezed in, but you might come up here and say this is x1 and this is y1, and then you might say this is x2 and this is y2. If that helps you, go ahead and do that, all right? You don't have to, though. So with that, you guys should clearly be able to see how I'm getting minus 1, minus 2, that's y2 minus y1, over 0 minus a negative 3. And from here, I just simplify. So minus 1 minus 2 is negative 3. Two negatives here make positives, so this is a positive 3. Negative 3 over 3 simplifies to negative 1. All right, so now I need to show that that has the same slope as CD, right? That's the side I chose to compare it to. So who do I want to pick on? Let's do Austin. How am I going to start my next line? What am I going to write? Very good. I don't need to write this formula every time, so I can go straight into my points. For CD, you've got a separate pair of x1, x2, y1, y2, right? So now this is your x1, x2 over here. I'm sorry, I did that backwards. x1, y1 is what I meant to write, and x2, y2. That's my new points. So if I plug that in, I'm going to get 1 minus 4 all over 8 minus 5. 1 minus 4 is negative 3. 8 minus 5 is 3. Okay, now don't just leave it hanging here. You've shown me two slopes, but I need to know that you know what that means. What do the same slope mean? Yep, so what I want you to do, and this is exactly how I want you to do it, is after writing your two lines, I want you to give me a bracket, including the work that shows you this thing, and I want you to tell me what is true. So you're telling me that AB is parallel to CD. So write the statement like that, using symbols. If it wasn't parallel, don't do this, but just watch. If you found that they didn't have the same slope, you would just put a dash through the parallel sign to show me that it's not parallel. Does that make sense? Okay. But these are parallel. So I now know that the two lines are parallel, but what else do I have to show if I want to say that these things are a parallelogram? Yep, I have to show that it's also congruent, right? All right, so I'm going to try and squeeze this in down here. My work is probably going to get a little squished, and I'm sorry about that. So I'm now going to try and show that they are congruent. Like I said, not very pretty, but we'll get there. Okay. So for congruent, you just tell me, you don't have to write m because I'm not finding a slope, right? You just tell me which side you're looking at. That means that you're finding the distance if you don't put an m in front of it. Okay. Anyone remember the distance formula? Square root. Mm-hmm. Yep, and I'm going to actually fill in with my letters. So he's saying that I'm going to take x2, which if we look up here is my x2. So I'll be putting in a 0, and what will I be doing after that? Minus an x1. Very good. So you subtract your x values, 0 minus a negative 3, and what do you do to that?
And then you add
Square it, and then you add the difference in your y's. Very good. So negative 1 minus 2. And you square that. So what I'm going to want to do here is simplify it and see what it equals. So I get, I'm going to do this in just a couple steps. Minus a negative 3 becomes plus 3. Square that is 9. Come over here to this stuff. Negative 1 minus 2 is negative 3. Square negative 3 is 9. So this is the square root of 18. Now the square root of 18 can simplify, but in this problem I'm not asking you what the distance is. I'm just telling you to show me that the distances are equal. So if you just show me that the other distance simplifies down to the square root of 18, of course those are the same. You don't have to simplify it. You just need to show me that it comes down to the same square rooted number. Does that make sense? Okay, so let's do CD. I probably am going to run just a little bit into the created with Doceri, and I'm sorry about that. I'll try and avoid it. So if I do DC, find the difference in your x values will be 8 minus 5 squared, plus the difference in your y values will be 1 minus 4 squared. Eight minus 5 is 3. Square that. 1 minus 4, negative 3. Square that. So this is the square root of 18 as well, right? So what would your conclusion be for this stuff? Distance doesn't say parallel. Distance says congruent. So you would say that AB is congruent to CD. Now, because of that, between these two things, do you have enough information to say that it's parallel? Or I'm sorry, a parallelogram, right? So what you would then do is kind of show me that both of these things mean parallelogram. I know I'm running out of space, sorry. So again, just to walk you through it, what you need to show me on a problem like this, if I give you 4 points and you need to show me that it's a parallelogram, what you should do is show me, first find out which sides are opposite, right? Pick the correct sides, that's the first key. If you pick the wrong sides, you're going to have a problem, okay? Show me the work for your slopes on both of them, labeling your work carefully. Tell me whether they're parallel or not, okay? Then you're going to want to, sorry about that, show me the distance work for both of your points and tell me whether they're congruent based off of that. If you get both parallel and congruent, it's a parallelogram. If one of these things falls through, what would you say? It's not a parallelogram, and you would show me why by putting an X through the parallel part or putting an X through the congruent part. Does anyone have any questions about what is expected on this problem? Again, this is going to be your most difficult problem, more tedious than anything. You know the slope formula, you know the distance formula, so that work shouldn't be new. It's what are you taking from your work, right?
Yeah, that's just part 1.
And that's just part 1. I'm going to be adding on to this throughout the chapter, yeah. So I'm telling you, these are going to become tedious, but they're going to be worth a lot, and if you just learn it, it won't be so bad. So really work hard on this section to make sure you understand this problem. You'll have 2 of them in your homework. Make sure you really work to get this work down on those, because I'm going to add to it on Friday. If you don't get this, it's going to be really difficult to add to. Come in for extra help if you need it.